Right, the layer 3 protocol, IPv6. We have a lot of reasons why we need to migrate to IPv6. One of the important reason is IPv4 is old. IPv4, because it is old, it is not capable of supporting the new things. For example, the size. The IP address size is only 32-bit in IPv4, which is not sufficient enough to meet all the network requirements today. We got various applications today which was not earlier using network. As a result, many end users have had come in and coming in every day. More the users, more IP addresses are needed, but 32 is a standard number you cannot increase. So we are moving to another standard called IPv6 standard, which is 128-bit size. This is one big reason. Second reason why we need to move to IPv6. IPv4 is like an old goods train. IPv4 is like an old goods train. I don't know whether it is same in every country. In India, the old goods train used to have a lot of box to carry goods. The engine and the boxes were tied together. Even when there is no goods to transport, still the engine will be pulling those boxes. Likewise, in IPv4 we got a lot of field. Some fields are used every time for communication, whereas most of the fields are not. So it is unnecessary burden for the devices that process the packet. I would like to repeat. The fields in IPv4 header is too many and very less are used all the time. Most of the fields are optionally used, once in a while used. The IPv4 header is not an extendable header. Because it is not an extendable header, we need to carry all those unused fields every time. Because once in a while you may need those fields to fill those items. So IPv4 have become burden. Whereas IPv6 headers are simplified headers. You will see only those necessary fields. And whenever you want new service to be added, the field also will get extended. For example, if I want to do IPsec authentication, you can extend the IPv6 header to support IPsec. Whereas in IPv4, it is not possible. You need to have additional ESP as a layer. See, IPv6 is designed to accommodate all those newly added network services. That's why I said IPv4 is old. So we are moving to IPv6. IPv4 is old. I still see in India many people hesitate to use Android phones because they're old. They think that this is not my phone. I cannot use this. They still need the dialer phones because they think that they cannot handle those Android phones, touch phones. Likewise, IPv6 header is like Android phone. Sorry, the dial phone. You cannot go WhatsApp. You cannot go any sophisticated application with it. You need IPv6 to adapt those sophisticated application. Only then you can have application aware policies in routing. For example, segment routing. Segment routing is one of the excellent service that we kindly mute service that we mostly see in service provider side, with which we can have policy-based path selection, for which IPv6 is ready to adapt it. Whereas IPv4, you need an MPLS header to have segment routing. In IPv6, the headers are extendable. So the segment IDs, the values that are needed for segment routing is attached to the header itself. See, in this class, I talk about many things which Bala do not know. I just want you to ignore those topics which I'm speaking in IPv6. But later in future, you will come across this topic if you are getting into service provider side, then you will know what I mean. But as of now, focus only on IPv6. Those additional stuff that which you don't know, don't see in your day-to-day life, just ignore those things. One point I want to make sure here that you know is IPv6 is the addressing which will be easy to use for today's network. So not only just because of size we are migrating from IPv4 to IPv6, there are much more reasons. One reason is extendable header, simplified header, and extendable header is IPv6. The other reason is in IPv4 we have a lot of attack surface like ARP, DHCP. These are all the areas using which the intruders may easily enter into our network. Because ARP does flooding, layer 2 flooding, DHCP does layer 2 flooding. Whenever you have that broadcast that is bad, that opens the gate for intruders to enter. Whereas when you move to IPv6, you don't have any service that uses broadcast. There is no more broadcast. Then how do we do ARP? Actually, we don't use ARP. What is the function of ARP? ARP is to do neighbor discovery. What do we mean by neighbor discovery? ARP used to learn the MAC address for the IP address that you want to reach. Now, what is that we have in IPv6 which fulfills that requirement? In IPv6, we have something called link local address and IPv6 multicast address, using which ICMP version 6 can do neighbor discovery, which we'll see later. So what I'm trying to show here is you still learn the MAC address of the neighbor, but not by flooding, not by broadcast, but by multicast. Because you are doing multicasting, only the intended devices will get the packet, not everyone. As a result, you got security. So totally broadcast is avoided in IPv6. We do have DHCP in IPv6, but the purpose of DHCP in IPv4 and in IPv6 is slightly different. In IPv4, we have DHCP to give IP address, subnet mask, gateway, DNS address, Win server address, etc. Whereas at IPv6, we don't use DHCP to give IP address. IP address is auto-configured. Then why do we need DHCP in IPv6? Just to advertise those DNS address and other Win server address and etc. only. So there is no broadcast in IPv6. We have only unicast and multicast, no broadcast in IPv6. Not only that, you will see we no need even NATing. Network address translation in IPv4 is unavoidable. It cannot be avoided. Wherever you want to go online, you will do NATing. Without NATing, I'm not available for you to communicate. I cannot communicate to you, you cannot communicate to me without NATing. Whereas in IPv6, there is no need for NATing. Now, what is NATing? We translate from one address to another address. Which address to which address? Most of the time, we do translation between private to public and vice versa. Why do we have public and private address? Because in IPv4, we got only 32-bit, which is not sufficient to provide IP address to the entire world. So we got private scheme. Now, when you have private addresses, you cannot talk to public. Before talking to public, you translate your own address into a routable public address, which is what we call it as NATing. Now, NATing is not needed in IPv6. What does that mean? It means that there is no private address in IPv6. Do you agree? If there is no NATing in IPv6, it means that there is no private address. Yes, there is no need for a private address. There's no need for a private address because IPv6 is very big. 128-bit is very big. Because IPv6 is very big, we give public address to everyone on the earth. As a result, all are in public. No need for translation. No need for translation. So there is no NAT in IPv6. But during those migration days, some may use, not everyone will use that because it's not a recommended way of migration. There is a method called NATPT. So you should not say that, you Jay say there is no NAT, but I have something called NATPT. NATPT is not NAT. I said no NAT, but this is NAT protocol translation, meaning you translate from IPv4 protocol to IPv6 protocol and vice versa. That is seen in few places. We call that as NATPT. That is a migration strategy which someone uses. What does it mean? It means that customer is not ready to migrate to IPv6 immediately, but the provider is forcing him. When the provider forces to use IPv6, customer will say no. Who are you? Who are you to force me? I will simply translate from 4 to 6 before going to online. I will not change. I will still continue using 4. I will simply translate. And when the ISP receives the packet from the customer, he receives packet from the IPv6 address because it has been translated from 4 to 6 before sending it out. So The customer pays a big price for this. What? If you want to do NAT PT, you really need to spend a big amount of processor, because every single packet, you are totally changing the header before sending it out, not just one IP address. NATing is simply changing one address, source address, from IPv4 address to destination IPv4, sorry, another mapped address, mapped IPv4 address. Normal NATing is simply changing a source address. If it is destination based, changing only the destination IP address. That is normal NATing. But NAT PT is not that simple. NAT PT is protocol translation. You're translating from IPv4 to IPv6. You're translating from IPv4 to IPv6. If you go to some banks in India, they will have the challan, the paying slip, in Hindi language, which I really don't know to read nor to speak. What do? I only see that one MS, MR, Mr., Miss. Okay, I understand. This is the place I need to put my name. And I see the symbol and I fill the amount and I sign and I give. So I no need to translate every single line of the challan, because I know the challan earlier. I have seen that in paying slip many times in English. So I no need to read and understand every line in the paying slip. I translate only that area where I need to put my name, the date, and the signature and the amount. That is easy, you know. That is simple NAT. But NAT PT is, I never seen the pay and slip earlier. I really did not know where to put the account number, where to put the money value, where to put the name, where to put the date. So I asked someone to read every single line from Hindi and translate it to English. That is totally different. It's going to take a lot of time. NAT PT is like that. A worst migration technique is NAT PT, NAT protocol translation. You remove the entire header from the packet layer 3 IPv4 header and put it as IPv6 header. And when you receive the packet, you remove the IPv6 header and put back IPv4. This is going to be a lot of CPU. So when I say there is no NAT, trust me, there is no NAT. Next. As I said earlier, you don't have DHCP. Addresses can be automatically configured without a DHCP server. We call it as auto-config. How is that possible? How is that possible? Now, if I need to call myself as an Afghani, I need to go simply say, my name is Jayachandran. Then they will believe me. They will trust me as an Afghani. Because my name ends with Afghani. I become citizen of Afghanistan when I say Jay Afghani. Aaron Afghani. I became a citizen of Afghanistan because I added that magic word and I enrolled myself as a member of Afghanistan. Likewise, if a device needs to talk to an existing network, it needs to add that Afghani. It needs to find that network portion and add to the host portion, isn't it? For example, in IPv4, if you have a computer, and if I want to connect a computer to these two computers, if I want C to communicate to this A and B, I need an address starting with 10, isn't it? This is what that Afghani, I mean Afghani. If I know that Afghani magic word, I can put some number and I can become the member of that Afghanistan. So all that you need is the network portion. If you know the network portion of the network to which you want to connect, you can have your own host portion by adding your own unique ID. What is your own unique ID on the computer? What is the unique ID that computer has got? What is the unique ID that computers have got? No. Every computer has got a unique ID. What is that unique ID? Every
Unique ID
computer
is
has
10,
got
right?
a unique ID. What do we call that unique ID as?
It's
Exactly, the MAC address. So if I know this Afghani 2000, this 2000
the MAC
is the
address.
network to which I need to communicate. If someone will tell me, hey, we got 2000, if someone will tell me that, then I can take the 2000, add my MAC address as the host portion, and I can become the part of this network. For this, why I need DHCP, you tell me? There is no need for DHCP. See, smart move. It's a very smart move. We need an ICMP version 6 to tell the network portion using multicast. And only this IPv6 enabled router can receive the multicast signal. In that, it understands that the network to which I am physically connected is 2000. So what this computer C does is, it takes that network portion, puts that MAC address of this computer's MAC address, and it builds its own unique address. Now, if you go here and ping, it will ping. You will get reply. There is no need for DHCP. We call it as auto address configuration. Even the configuration will go like this. You go under the router's interface and say IPv6 address auto configure. Right. So these are all these things we will be seeing in lab as well again. Now, what I'm trying to say here is we don't use DHCP. There is no more stateful DHCP. IPv4 DHCP is a stateful DHCP. What do I mean by stateful DHCP? It takes the MAC address of the device that comes to register with the DHCP server, and the DHCP server, after registering the clients by taking their MAC address, it provides an address from the pool, from the address pool. Okay, now we have seen some of the advantages. The best, please.
Sir, one thing, I have doubt.
I did not say it will
How
assign by
system
default.
will assign 2000 by
If
default?
you say how 2000 is dynamically assigned, then I can answer you. I did not say by default 2000.
It will,
How it can be dynamically learned or something like that, you are asking?
yeah,
That's what I was telling you. Using ICMP version 6, these devices will be sending,
yeah, yeah,
using this
yeah,
protocol, using a
dynamically.
multicast address, they'll be sending this information for this PC to learn. Because in this PC, I told auto address config. Immediately, this PC will will send a special message. In that special message, these devices will come to know the multicast address of this guy. So to that multicast address, they advertise the network portion. And using that network portion, by adding the MAC address, C can have its own unique address. More detail will come when we do the lab. So addresses are auto-configured. It's a very simple thing for IPv6 to do, but it
Okay,
needs
sure.
that multicast FF02 colon 2. So only when you have this router multicast group enabled, this is possible. I think I'm going in a highway. I don't want to go in a highway. We have still not hit the highway. We are on the mud road, the cross side, maybe the service road. Let's go slowly. So far, what you should know after this many minutes of me delivering is IPv6 is the better option for today's network. IPv6 is 128-bit size. IPv6 never uses broadcast as a service. IPv6 don't need ARP or DHCP. IPv6 don't do, there is no need for NATing. All other things that I spoke are going to come again, like NATPT, auto address config, all those things are coming late. Now, going to the IPv6 addressing itself. If you take IPv6 address, there is a connection in IPv4. There is a number called 8. Do you know where we have number 8 in IPv4? Each octet is 8-bit. In IPv6 also we will see 8. In IPv4 we have 32. Why we have 32 in IPv4?
8 bits.
Because the total number of binary bit in IPv4 is 32. Here also we will see some 32. Okay. So there is some sort of connection between IPv4 and IPv6.
32.
Now, in IPv4, that 128 bit is a binary bit. In IPv6. In IPv4, it is 32 binary bit. Now in IPv6, if I need to write in binary, it will go page of 011 because 128 characters I need to write, and all are zeros and ones. So instead of Instead of writing in a binary form, in IPv4 we used to write it in decimal. Have you ever typed IPv4 address in a binary form? I never. I've never. I've never typed zeros and ones as an address in IPv4. I have always typed like this: 200 dot 1 something like this. This is decimal. So just for 32-bit itself, we are not ready to write in binary, and when you are writing in decimal, definitely we are not going to use that binary in IPv6. We will try to use something better than decimal. Yes, we use hexadecimal. IPv6 is 32-bit hexadecimal. How 32-bit hexadecimal? How can 128-bit binary becomes 32-bit hexa? The biggest number in hexa is, what is the biggest number in hexa? What is the biggest number in decimal? What is the biggest number in decimal? 9 is the biggest number. 0 to 9, totally 10 numbers. Now hexadecimal means what? 6 plus
Like 9.
9. 6 plus 0 to 9, which
0
is
to
10.
9.
6 plus
Yeah.
10 is what? 60. But because you start from 0, it is 15. 15 is the biggest number in hexadecimal. Now,
16.
in hexadecimal, to write 15, we say F. Do you know that? In hexadecimal, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 starts A. F. That's all. Totally 16 numbers. This is 10, this is 11, this is 12, this is 13, this is 14, and this is 15. Okay. Now, to write 15 in binary, how many bits you need? To write 15 in binary, how many bits you need? I think you just finished subnetting, you know. 4 bits. 1 plus 1 plus 1, 1 plus 2 plus 4 plus 8.
15.
It's 15, isn't it?
Yeah.
So,
4 bits.
1 bit of hexa is equal to 4 bit of
2 plus 3.
what?
8.
Binary. If 1 bit of hexa is
Yeah.
4 bit of binary, if I need to convert this binary into hexa, I need to divide by 4. 128 divided by 4 is what?
Binary.
32. So hexadecimal is 32-bit in size. Sorry, IPv6 is 32-bit hexadecimal address.
32.
Okay. I told you there is a connection between these numbers. Here you know what is 32, here you know what is 32. What is the size of IPv4 address? 32-bit. What is the size of IPv6 address? 32-bit. No? Both are same. Number is same.
32-bit.
But number system is different.
128.
This is
32-bit
32-bit
of
binary.
hexadecimal.
This is 32-bit hexadecimal. So there is some connection, you see.
Yeah. How it,
Now, what is the connection between this 8 and this 8? In IPv4, every octet is 8-bit. So totally you have 4 octets. Here, this 128-bit is written in 32-bit hexa. Yes or no? We just learned, no? 32-bit hexa is 128-bit binary. Now, the 32-bit is equally divided into 8 groups. How
yeah.
many?
Binary.
8 groups. You see? With a colon.
32-bit hexadecimal.
1,
32-bit
2,
hexadecimal divided into 4
3,
groups or
4, 5,
okay.
8. See, there's a connection between IPv4 and IPv6. The numbers are connected. No other way connected. So here also you have a 8 hexadate. Why I call this as hexadate? Because I have 16-bit. We just learned that 1 hexabit is equal to 4 bit of binary, isn't it? Then 4 multiplied by 4 is what? 16. Yeah, hexadate. So this is 16 multiplied by 8 is
Yeah.
128.
16.
Okay.
4.
Now let's move on to the next one. We just learned that the 128 bit
128.
is divided into 8 hexadates. Now, this is 128 bit. You should know that. When I divide this is 64 bit. And this is 64 bit. Size
Yeah.
of IPv4 is what? The 32 is
64.
smaller than this 64. Even LKG student will know that. But what I
Size
mean
of
here is
IPv4 32.
your entire world is now running only with this 32 bit. But now you got only for network portion alone 64 bit. Only for network alone.
Yeah.
We call it as global prefix. We don't say network ID. In IPv4, we used to say network ID, host ID. Here we call it as global prefix, meaning the network portion of the address. And this 64 is the interface prefix. We don't say host ID. We call it as interface prefix. Yeah, this is the recommendation. So
first 64 is
the
global
network
prefix.
portion should be within
Second
this,
64 is
including
interface
subnetting.
prefix.
It's more than
Okay.
enough, I tell you. Today, the world is having IPv4 and it is only 32 bit. You just got both the host portion and the network portion.
Okay.
Here for network itself is 64 bit. It's too much actually. So if you want to do subnetting, very easy subnetting here. The reason is you will not borrow. This 16-bit is recommended to be used only for subnetting. So whenever you have a network and you want to do subnetting, just add 1, that becomes one subnet. Add 2, it becomes another subnet. 3, it can go up to F. And then you start here. 1, 0, 1, 2, 0, 1, 0, 1, 1, 1, 2, something like that. You have 16 bits, so you will have at least 65,000 subnets from each network. So subnetting is nothing here. It's not like IPv4. Just you need to turn on some bits in this portion, in the fourth hex straight from the left. So global prefix means the network identification portion of the address. Interface prefix is the host identification portion of the network. Now I'm going to write an address. But before that, I'm going to write an address, which is an example for IPv6. You see this address, 2000, valid address. But we don't need to type this big address like this, many zeros. We can avoid it. We should not remove this because this is 2000. If you remove that 00, it becomes 2. So you cannot do that. Colon. Instead of writing like this, you can put only 10. And now this leading zeros have got no value. So you can put 1. No value. So put 1. Now, instead of this consecutive zeros, you can simply put colon, colon. That's it. You don't need to even fill zeros. Not even 10. Instead of all these consecutive zeros can be written like this. And this leading zeros, remove and put 1. That's all. Both are same. Any question? What we should not do is, we should not do this. We can have only once
No questions.
like this. You cannot have more than 1. So if you want to put here like this, then you should put 3 zeros here. Either you do that or do this. For one set of 0, I put 1 0 0 0. Either you put space instead of all this, or put space instead of all this. Because you have used 1, you cannot use again. So your wish, but what I recommend is, even though this is also right, this is also right, do this, which we did earlier. This is the best one. This is the most appropriate one. But all 3 are right. This is the most exact shrinking of address. Only once. Now, matter, doesn't matter. If it is consecutive, then put 0. Sorry, you just put space.
For all zeros, we need to give this space. That's all, right? For any, if it is 4 or if it is 3, if it is 2, doesn't. I mean, for all doesn't matter. Okay, space. Okay,
No,
sir. We put directly like IPv6 address. So in this
we don't
case,
have classification.
do we have like a class A, class B, class C in IPv6? Okay.
Yes. Mm.
Okay.
Sky is the limit,
Because
but
in
it
IPv4
starts
we have class A,
with
class
2000.
B, and class C. So how the
Any
IP address
IPv6
starts
you
in
take in
IPv6 from
on
where to
Earth
where?
today, it will start
From
with
where it will start?
2000.
Because that's
It may be 2000 or 2001 or 2002 or 2003 or 2004, something like that. But you will never see an IP address starting with 1 colon or
okay.
500 colon. No, it starts only with 2000. Because in the year of 2000, it became standard. IPv6 became standard. There's no other reason why they start with 2000. That's the only reason. Now, all the global address
Okay.
will start with 2000. And link local address, there is a type of address called link local. They start with FE80. We'll discuss on this later. Yeah, yeah. There is no other option.
So link
FE80
local.
is the only option.
Okay. By
Link local
default,
means
the
FE80.
standard. I mean the FE80 link local. Okay.
Colon 1 loopback address.
Okay.
FF00 multicast address. Right? So these are the address types that we have. There was also two more, but now it is no more. It is removed from the stand.
Mm-hmm.
Those are all removed. There is something called, that is what I was about to say, FEC0 and
Site local.
FED0.
Site local.
These are all no more in standard. They are removed.
Remote. Okay. Unique local.
They were
Unique
all
local.
used as a site local, means local, like a private address earlier. They were thinking like, no, we should use something like this, but later there is no need for private address, so this is no
What is
more.
FEC0, sir?
No more. You should not use these things.
Okay. Okay.
Check
Okay. If it is
internet.
removed, but what it stands
Because
for?
it's no more. It's no
FED0,
more there in the
FEC0, and
standard for more than
FEC0
10
site
years
local.
now.
What about
It's no more.
FED0?
All right. So site local address
Okay.
and whatever. Please try
Okay.
checking that. It's not useful
Okay.
again.
Yeah. Sure.
So I don't remember. Now from here we will see in our next class.
Okay. Yes.